Good morning, everyone, and thanks, Abel, for the introduction and for inviting me to give this presentation. Like Abel said before, I'm using this opportunity of our recent book on blockchain to cover the recent advances that we thought are really interesting to share with you. So first of all, my name is Mohamad Kassem. I am currently a professor of digital construction at Newcastle University. I've been doing research on digital construction since 2008, covering, starting with BIM, digital twin AI, and over the last few years also blockchain. So my plan for this presentation, I guess I'm the first presenter, so I will start with a few definitions, although I think many of you are aware of these definitions, but just in case someone is not aware, so it's good to cover the foundations. Then I will a little bit talk about our motivation to write the book very briefly, give you a flavor about its content, what the recent advances and area covered by the book, and pick up three of the topics covered in the book and go a little bit with some details through those three areas. So I guess many of you are familiar with what DLT is. DLT is this decentralized network for storing information digitally. It has no single point of control or failure. It's cryptographically secure when with encryption, protecting data integrity throughout the network. It's transparent to all or selected participant, depending whether it's a permissionless or permissioned. It's also synchronized where nodes maintain consistent, up-to-date copies of the ledger. Um, what's the difference between blockchain and DLT? Often these two terms are used interchangeably. We could say blockchain is a specific type of DLT in which a linear chain links the code, the nodes or blocks together. Unlike blockchain, DLT can use various structure to create decentralized network such as DAG or hash graphs. DAG is usually the most popular structure for DLTs. The reason behind developing DLT structure like DAG is to solve some of the inefficiencies with traditional blockchain, with blockchain, such as the need for higher scalability, faster transaction, lower transaction cost, better energy efficiency. However, on the other hand, DLT still suffer from low decentralization. Its structure is more decentralized, but the social system around it, you tend to have a smaller set of validators, or they are governed by councils or committees, so they make them less centralized than blockchain really. Security maturity is weaker in DLT compared to blockchain, and still there is limited real-world load testing in that type of network compared to blockchain. Also, the ecosystem for DLT is smaller, and there's still some issues with consistency. There could be instances where the node reference different when the node reference the different transactions simultaneously, there is a possibility to have inconsistent view across the ledger in case of issues like communication lag. The other concept really, I think many will be, I know it was introduced as smart legal contract by Abel previously, and we have Gavin later on, who is a top expert, who will be talking about smart legal about this topic. But smart contracts, really interestingly, they aren't smart and they aren't contracts. The contract usually are legal agreement. These smart contracts, they aren't contracts, so they are just self-executing digital program. A good analogy, really, you see there is a vending machine. Is a good analogy for smart contract where like you insert the money, the condition is met, the machine dispense your what you bought, the action is executed, there is no intermediary, and everything is automatic and transparent. So we'll hear more about that later on in the from Gavin and other presenter. Very important concept, I think, for blockchain application and DLT application in built environment is the concept of oracles, which are the agents that connect blockchain to the external world. In this case, we have human oracles, could be design manager, project manager, quantity surveyor. We have software oracles in the case of built environment. They were mentioned earlier by Able, BIM solution, AI tools, document management system, and so on, as well as hardware oracle, as again mentioned by Able recently, as previously, such as IoT sensor and other devices that transmit data from physical world to blockchain application. So this is enough for in terms of background. So why we decided to write books nowadays? As you know, books really comes out like mushrooms every day. There's some book published. Why three busy individual like us would come together to publish another book? The short answer really is we responded to a significant gap and need. So when we looked at the emerging research and what's available out there, there wasn't any single monograph or book that bring a holistic understanding of DLT application and blockchain application in built environment. So we couldn't find a resource that covers the whole life cycle. We couldn't find a something that really, because we know there's lots of speculation around blockchain and DLT application in built environment has lots of as well. I know lots of academics who are really opposed to do any research on blockchain in built environment. So we needed a sensitive resource that that's not that reduce speculation and it's honest and upfront about where is the state of the art, what are the limitations, and clearly mention if something is high level thinking, speculative, or it's a prototype or proof of concept. So we brought together really a great team from leading, great team of authors from all around the world to bring this book together that covered really the whole life cycle, and we thought it would be good to bring a group of experts who are interdisciplinary as well, from the domain of construction informatics, built environment informatics, and we covered both conceptual and technical topics as well as applications that involve incremental improvements, such as, for example, automating transaction in a traditional contract, and also transformative innovation, such as, for example, changing the architectural collaboration or architectural process through DAO and things like that. So what you find in our book, we have a range of topics. So we cover as well we undertake a socio-technical approach to blockchain. We have two chapters on that with Jennifer Lee and David Greenwood. We define really blockchain as a domain. What is it in socio-technically? Who are the actors at macro level? What are the aspects that should be involved at market level, but also at meso level, at organization and use case level. And we have roadmaps as well on how to approach the adoption and implementation of blockchain, both at market level, but also at use case and application level. We have, in line with the theme of this CBC 2025, we have quite a lot on information security and digital trust written by a team like Jack Chang and his team, based on secure data sharing and collaboration, something I will cover in my presentation. Tokenization of built assets, a very important topic. I think Lavinia is talking about it, and also Gavin later on. So is a topic as well that I chose as well to talk about it today out of this book. Digital building logbook, it's really very emerging development all over Europe and the rest of the world. There isn't a predominant technical approach that's currently working perfectly for that domain. So we have Daniel Hall, TU Dunas, Demos, and their and their collaborator developing their vision for a blockchain-based digital building logbooks. We have the team from Cardiff University talking about discussing energy management through the use of blockchain and smart contracts. And we have the DAO for architectural design by Theo Dunas. Prof. Wilson, who couldn't speak this morning, grateful to him because I need to be in the stadium later on this afternoon watching Newcastle Man City. So he wrote for us on construction supply chain in terms of cross-border logistic, material traceability. We have Abel, who wrote with his team, who wrote a chapter on data observability and digital twin. My PhD student Maher and David, and with Professor David Greenwood, we wrote a couple of chapters on smart contract, automated payment, dispute resolution. And Gavin wrote really a very interesting chapter on legal and regulatory framework. On top of all these applications covered in the book, we have as well some very, very in-depth analysis that go across all these applications, identify commonalities and differences in the conclusion chapter, as well as a roadmap for the industry, talking about the ecosystem of blockchain adoption, the low startup contact environments that currently surround blockchain in construction, and how blockchain application could move in the AEC sector. So that's in terms of book. As I said, I chose three areas. Hopefully, I can cover all of them. If I can cover all of them, I skip one in terms of time. The first one is the tokenization of built assets. This chapter was written by Lavinia, Paulo, and Algan. I checked with Lavinia. Hopefully, I'm not spoiling her presentation, which will come after mine. Why we need, what are the issue with traditional built asset and real estate sector? Really, there is a lot to dislike about the traditional housing market. Real estate is, as the name suggests, real property. It exists in real life. While this is one disadvantage, it's also a disadvantage. It forces the market to be binary. So we either have full ownership or no ownership. It creates barrier for investor participation. It reduces innovation. It's not easy nor quick to buy, sell, or trade real property. If you have bought in recent years some property, you know about it. It's also expensive and could be fraudulent as well. Um, Tokenization is a way of representing a piece of real estate as tradable digital security token. These tradable digital tokens are secured by blockchain technology. What are the benefits from that? Greater liquidity. We can buy a fraction of a property. There are some blockchain now in Emirates, in Dubai. They require less, about $1,000 to participate. Low entry cost, of course, the initial investment is minimal. You don't need, that massive deposit in order to invest in property. Enhanced transparency and security through reliable, tamper-resistant record of ownership and transaction. You can open the market for global investment as well, and you can be, of course, more efficient, which is one of the biggest issues in current real estate as well. And there are evidence that this efficiency is really attractive for high worth investors they look for this, and they're really focusing on tokenization of real estate. Well, what I say, it sounds utopian. We are basically, because I show you a set of challenges and I show you a set of benefits that tokenization bring. So, however, the question now is how we can do it and what are the challenges. I don't want to show the actual reference architecture that Lavinia and her friend showed in that chapter. I just talk about the ingredient of their technical framework. So basically, before blockchain and smart contract, this use case of tokenization would have been really science fiction. Now, with the emergence of these technologies, we have some serious attempt, both in academia and industry, that trying to perform the tokenization. What you see here in this slide really as an ingredient of the technological framework presented in our book by Lavinia and her colleagues. GIS is used for spatial analytics metric. Basically, it brings in data about that planning, development, distribution of assets. So it brings that layer of high-level analytics linked to the urban scale. While BIM provide a building level model enriched with ownership records, energy certification, and architectural parameters, these are really critical for these are critical details when assets are fractionalized or traded. Um, in terms of systems, they are as well, according to the chapter and the authors, there are already token standards that can represent that are flexible in terms of representing the ownership, whether it's a fungible, non-fungible, or non-transferable credential like certificates and so on. So there is flexibility in terms of modeling different kind of ownership, and the smart contract are able to automate asset transfer and embed predefined legal obligation into the digital transaction. So this is conceptually the digital system that support also real-time notarization, can facilitate asset segmentation and governance. In the chapter, if you, I'm not trying to sell the book, but there are a lot on really deep discussion around business model, tokens, and different type of smart contracts that support this framework. We don't have time to cover all of that. So I don't want to, as I said, I don't want to sound utopian. So what are the challenges facing tokenization? The first one is really legal ambiguity. This is perhaps the most significant challenge. Tokenized ownership is still unrecognized in many jurisdictions. There are also technical vulnerability if the standard contract is poorly written. Um, there could be as well concern about lack of privacy, preserving features. This can deter trust. But also there is cultural resistance, particularly from notary councils and traditional legal actors. There is a resistance from the incumbent player in the real estate market as well. Um, there is no established system for whether token may be bought, sold, or redeemed in conventional currencies as well, or cryptocurrencies. So there are challenges. However, despite all these challenges, tokenizations seems to be. I did a research on before I put this slide. It seems that tokenization is really the future of ownership. It's going to be the future of ownership, whether we talk about stocks, bonds, or real estate. Expert agrees that tokenization is here to stay, and they argue that the biggest challenge standing in the way is digital verification. So you can see on the slides there are lots of attempt. Like in Sweden, there was really some interesting pilots that worked very well. Was able to was able to achieve digital signatories, smart contract orchestration of different parts of the conveyancing process, and direct interaction between buyer, seller, and also the registry. It shows faster registration of ownership change, better transparency of transaction, and reduced error in the paperwork. But what didn't work in that pilot is that it was of course, it was a proof of concept, but the legal institutional organizational hurdle remained. Swedish law still requires certain paper contract and wet signature in some parts, and there were resistance from the incumbents. But there are other attempts around the world. Dubai has just launched in 2025 a major tokenization project. They have a virtual asset regulatory authorities called VARA, and they aim to put in by I think 2030 they want 7% of all real estate transaction to be in blockchain, and there is success story as well in Luxembourg. So the area is here to stay. There are some barrier around it, but it's there are a major investment around it. So it's really likely to continue, and as I mentioned before, to really change the way ownership is understood. So that's one area in our book. The second area is data security in architecture, engineering, and construction projects, a topic that was written for us by Jack Chang and his team, Momita and Xing Yu. This is very interesting area. Basically, what they argue here in their section, they argue that information management in construction still depend on central system. These centralized system like common data environment are hosted by usually by lead contractor, and other project party are invited to participate. Such a setting creates vulnerability. We have a single point of failure. We have trust issue because one party control data access. If they decide to exclude another player from access to information, so there is a possibility of trust. But the biggest issue as well is non-repudiation capability in current CDE system. Without non-repudiation, dispute become difficult to resolve and accountability become nearly impossible to enforce in the contract-based temporary organizational structures that we have in the construction and built environment sector. So they took all these challenges, and in addition to these inherent characteristic, we could have as well malicious issues in AECO collaboration. We could have external cyber attack where unauthorized access can form a threat to information within project. We could have internal access denial, where a malicious internal actor stop another actor from accessing information. We had so far in the UK, there has been one case that ended up in court on that. And we have data integrity threats where for some unauthorized modification or corruption of project happen within the system, and it's really difficult to trace and different to identify accountability in this case. So taking all these like inherent characteristic and malicious issues that could happen for the information in built environment, they presented really a very, very articulated and very detailed framework for secure information management in construction. It's really like there are about 4 pages in the chapter on that, but briefly, they broke down the problem into 3 areas: digital confidentiality, digital trust, and digital data utility. Data confidentiality basically is about protecting sensitive project information from unauthorized access or accidental disclosure. They separated between data at rest and data during data in transit. And they found that from encryption point of view, there are no problem in terms of bringing in blockchain technologies that enable to perform encryption for both type of data at rest and data in transit. However, the challenge that they found, it's basically it has to do not only with confidentiality, it's about how we can make data confidential without undermining collaboration. Because for example, if um, you need basically we need a segmentation sensitive approach to the information within BIM models where we can set up something, they call it selective transparency. So, for example, an architect might be privy about a specific architectural facade or wall elements, while a contractor might want to protect other commercial information or schedule information and so on. So how we can bring this selective transparency system in place. So they came up with this system. However, that system defined under data utility. Then they have the second dimension, which is digital trust, which is about the confidence of individual organization and systems that project information is stored and disseminated securely. They broke that into data integrity, data availability, and data traceability. For each of those three concepts, they showed how a blockchain can overcome the issues that we have in current systems. And finally, data traceability was a key one. Basically, through blockchain solution, we can ensure that we have a verifiability of endorsement. We can have irreversibility of audit trails, which are key for the non-repudiation capabilities that we have in current system. Similarly, they came up with the data utility concept, and they implemented a selective transparency systems where you can identify and categorize sensitive information, apply specific method for each type of information to securely expose the information. So it's really a very, very detailed concept that really push the boundaries in terms of cybersecurity for AEC information. So on top of that, what they did is they developed a technical reference architecture to implement that. Um, so what they do is they they bring in what we call it IPFS, interplanetary file systems that can be used to store the information, because they argue that blockchain is not best to store all the BIM information. We can store the metadata of the information, but the information is stored in IPFS network, which are peer-to-peer databases. IPFS, they also provide really a flexible infrastructure, because you can set up peer node belonging to one organization or working groups. Each cluster can have their own unique key to allow them to access the data. In addition to that, there is an opportunity to develop what we call it full node and light node, where full node you can be a core project member, like an architect who have access to the whole data set, or light node could be external authority who need to access just to verify things related to e-submission and e-tendering. So the system is tested and demonstrated in that chapter, and can allow really an advanced way of information management within secure information management in AEC project. Um, the final application I want to cover is decentralized digital building logbook. I think you is speaking later on. So what's being argued here in this chapter is they look at the DBL from the angle of whole life cycle and circularity and sustainable built environment. And basically, we require information, historical information, require information about material, energy, performance, ownership, and change. And the current issues with digital building logbook is that the way they are conceived currently, using centralized systems, there is low incentive for stakeholder to update the information. There are high administrative costs to maintain the digital logbook. There are no clear funding model, and there is weak interoperability, privacy, and security across the systems that feed into the digital building logbook centralized system. These are the existing technical approaches, which I have just mentioned: centralized platform and linked data semantic web, that both don't seem to be resolving the issues we have in terms of incentives, in terms of interoperability, to maintain digital building logbook alive and over the whole life cycle and beyond. So they presented this framework that has three core layers: the data layer. Interestingly, in this data layer, they separate between legacy information and non-legacy information. So data is stored either on a decentralized data network, are linked cryptographically to legacy databases. So they propose a blockchain architecture that supports the integration of existing older building data, ensuring that historical information is preserved. At the same time, they allow for the system to host a new building with IoT integration to maintain consistent and secure data. They have the logistic and service layer, at the core of which there is smart contract to automate the recording of changes to the DBL. They suggest that such a framework is best operated on a proof of stake blockchain. This contract provides a secure and efficient way to handle transaction and update, minimizing error and enhancing processing speed. Finally, we have the use layer, use case for various sets of stakeholders. They implement, they haven't implemented it, but it's a conceptual framework, but they suggest a crypto economic incentive system to introduce incentive for various stakeholders to participate and update the digital building logbook, so they can encourage honest participation and enhancing data integrity and reliability. And the participation, of course, is decentralized. Various stakeholders, such as owner, regulator, and builder, participate without a central authority. And this increases engagement and accessibility within the system. So their vision really is to ultimately develop a cryptographically secure digital building twin, providing a detailed, immutable record of the building data across its whole life cycle. I think I've seen recently a post by Tio on LinkedIn. Seems that thinking of this has advanced significantly. We'll hear from him later on. My final slide, I'm not sure how I'm doing on time. What I want to stress really is that across all these area I mentioned at the beginning that are included in the book, not only the three I covered with a little bit of depth in this presentation, we made sure that our author cover like what's the problem, what's the use case, what's the problem statement, what's the solution they are proposing. Is it a proof of concept? Is it somehow a little bit speculative, or is it like something like tested in an operational environment? And what are the implication, limitation, and future direction of research in that area. So you find application within our book covering the whole life cycle from design all the way to O&M with all that structure in mind. So that's all what I want to say. Happy to take question. Thank you for your attention.